Phytoplankton is projected to produce less organic material as the ocean's temperatures rise. With surface waters warming, their density diverges more and more from deeper layers and less mixing can take place. If less water from the deep reaches the surface, fewer nutrients are available for phytoplankton and primary production decreases. This is what many model calculations have shown. We, a team of scientists from Kiel and Sydney, suggest that this assumption might be misleading. The trend of ocean primary production going down due to climate change seems to hold true for the next 100 years. But if we look beyond that period, our model suggests that ocean production increases. Now, this isn't a change back to production as it was before we added a lot of carbon dioxide to the system. This is a shift to a fundamentally different type of production. We integrated a 600-year simulation using a medium complexity Earth system model starting in the year 1800, before the Industrial Revolution. In this way, we were able to cover historical carbon dioxide emissions and a business-as-usual emission scenario to see how the ocean biology would respond. We used 3 slightly different model versions. When we look past the next 100 years, we see primary production start to increase, and not just a little bit, it increases by a lot and fast. So we asked why. And it's the difference between production and breakdown rates, or respiration rates, that's driving this increase in primary production in our models. We analyzed how the ratio of primary production to respiration changes with time over our simulation. Each model version shows a slightly different response, but the major pattern holds, which is that over the first 200 years, this ratio between primary production and respiration rates changes very little. But then starting about the year 2000, we start to see a decline in this ratio, and that's because respiration rates are picking up faster because they're more sensitive to increasing temperatures. Looking at the next 100 years and on into the future, we see this ratio continue to decline. Eventually, this unbalanced ratio pushes primary production out of a regime that's regulated mostly by physical limitations like access to light, temperature, and nutrients, and into a new regime that's dominated basically by the biology itself. Now, this new regime is different from the one we're in now in that the nutrients are recycled very quickly in the surface ocean, and so deep ocean chemistry changes, and we don't see carbon being exported as effectively as it is now. Above a certain temperature threshold, the model physics becomes a lot less relevant for the biogeochemistry, and the biological model becomes a lot more important. Likewise, the eventual real-world primary production response to large increases in anthropogenic carbon dioxide emissions is going to depend largely on ecology. Exactly where that temperature threshold rests and whether it can be classified as a true tipping point is better addressed using a more complex model or set of models than what we used. If a tipping point is identified and we really can move the ocean into a state that's dominated more by respiration, then a question I would have is what happens to our global fisheries? Another question would be, how does this threshold compare to other climate guardrails such as the 2-degree temperature guardrail? I think this study brings up far more questions than it answers.